Let us now understand very clearly what are dependent events, what are independent events, how do we work with conditional probability problems and relate them with the Venn diagrams. An overview with great examples to explore in this video. Here is part of the question which I have discussed earlier. We have given you the probability distribution in the form of a Venn diagram for three different events A, B, and C. And now the question is state with reason whether events A and B are independent or not. And part K is to look into whether the events B and C are independent or not. Now, how do we figure out whether two events are dependent or independent? Well, the key is for independent events. Let's say we consider A and B, and if you want to check whether it's independent or dependent, so we say that what is the probability of intersection of the two events? So, what is the probability of intersection of the two events? That is what we are trying to figure out. Now, from the Venn diagram, the probability is sum of these two. Correct? So, let's add them. It is 0.05 plus 0.10, which is 0.15. Now, if this probability is same as probability of A times probability B, then it becomes independent, otherwise it is dependent. And now let's find what is the probability of A times probability of B. Now, probability of A is sum of these three, right? So let me write down 0.10 plus 0.05 plus 0.10. So that is probability of A, and we have to multiply this by probability of B, which is 0.17 plus 0.05 plus 0.10 plus 0.08. So that gives you what? Let's figure this out. So when you add these three for probability of A, you get 0.25 and multiply with the sum of the others, which is 5 and 0.4. And when you multiply these, you get not 0.15, but you get 0.10. Correct? So probability of A and B is 0.10. Since you can see that probability of A intersection B is not equal to probability of A times probability of B, we say that the events are not independent, or we can say they are dependent events, or we say not independent events. Make sense? So that is how you can say whether the events are dependent or not. Right? Okay. Now let's take up the other case, which is state the reason whether B and C are independent or not. So a better way could be first find probability of B, right? So probability of B is add all those things which we did earlier. 0.05 plus 0.10 plus 0.17 plus 0.08, and we got that as 0.40. Correct. Let's find probability of C, which is 0.10 plus 0.08 plus 0.27, right? That gives you 7 and 8 is 15, 5, 1, 3 and 1, 4. So 0.45, correct? Now, from the Venn diagram, you can see that probability of B intersection C is what? Well, probability of B intersection C is this, right? So we can write this as 0.10 plus 0.08, which is 0.18. Now, let's find what is the probability of B times probability of C. Probability of B being 0.40 multiplied by 0.45. What do you get? So when you multiply zero point 0.4 times 0.45, you get 0.18. Since they are same, right, this is equal to probability of B intersection C, we conclude that they are independent events. Makes sense, right? So that is how you conclude that they are independent events, right? So this process even better. Find probabilities of each event, then their intersection, and check whether the product of the probability is same or not. If it is same, as in this particular case, then the probabilities are independent. On probability and expected value. We'll consider two events A and B and figure out how does it make a difference if they are dependent events or if they are independent events. The example taken here will make you understand the basic difference and therefore will be very helpful in moving forward with a very clear concept. The question here is consider two events A and B where probability of A is 0.58, probability of B is 0.32. Calculate the following for different cases. A. Probability of A when B has occurred, it's a conditional probability, is 0.2, and A and B are not independent events. In that case, calculate probability of A intersection B and also calculate probability of A union B. Second case is A and B are independent events, and in that case, calculate probability of A intersection B and probability of A union B. So, for two different conditions, one when these events are independent, and the other when they are not independent, means dependent, you need to calculate same figures, intersection and union of probabilities for both the events. Perfect. I am Anil Kumar, and in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top, getting admission to the best universities. Little bit of guidance make huge difference. Okay, so now let's consider the solution of the problem at hand. So we are given two events A and B, and we are given their probability. So let's write down what is given to us. Probability of A being 0.58 and that of B is equal to 0.32. For part A, we are given that the probability of A when B has occurred is equal to zero point 0.2. Right. Now, under these circumstances, we need to find probability of A intersection B, right? Let's calculate the probability of A intersection B. We are given that this is not an independent event. That means it is a dependent event, right? So now we can find the probability of A intersection B as equal to. Now, since B has occurred, we need to multiply with probability of B the probability of A when B has occurred. You get the whole idea. So that is the intersection. So B has occurred, so find the probability of B. And now, what is the probability of A? So that should be equal to probability of B being 0.32. And we need to multiply by what is given to us, 0.2, which gives us 0.064. Make sense? So that is how you're going to find the probability of A intersection B. And now let's find out in part A, we're talking about dependent events, right? What is the probability of A union B? So probability of A union B is probability of A plus probability of B minus intersection or probability of A B. So that gives you probability of A is given to us as 0.58 plus 0.32 minus 0.2. Correct? So that should give you the right answer. So you can now calculate this value and write down your answer. Right? It is 7 over 10 or 0.7. Correct? So zero point 0.2 taken away 0.58 will be 0.38, and when you multiply add 38 and 32 you get 0.7. So that is how you do part A, which is a dependent event. Now let's do the independent event, part B. So in part B, we are given independent events. Now in case of independent events, probability of A intersection B should be equal to probability of A times probability of B, correct? And that is just multiply the given probabilities, which are right there for us. So probability of A is 0.58, and we're going to multiply this by 0.32. You can use the calculator, 0.58 times 0.32, and it gives you in decimals equal to 0.1856. So that becomes the probability of A intersection B, right? You see, it is very different from what we got earlier, right? Now, let's find the probability of A union B. So, probability of A union B will be probability of A plus probability of B minus probability of A intersection B. So, that is equal to 0.58 plus 0.32 minus 0.1856. And now we can calculate this, 0.58 plus 0.32 minus 0.1856. So that gives you 0.7144. Right? You can say approximately 0.7. Correct? So that is how we'll find the probability of A union B. You see, for two cases, it becomes absolutely different. And I hope with this example, you understand the concept of independent and dependent events also. They should help. So here is another important question. which is 120 grade 12 students are surveyed. For a student chosen at random from these 120, the probability that he has math is one third, and the probability that the student has both math and physics is one fourth. There are 20 students that do not have math or physics. So that is the situation given to us. First, you need to make a Venn diagram, and that should help you to answer the following questions. B is one of the student who joined the physics class is chosen at random. Find the probability that the student had also taken math. So we have a conditional probability question there. And C is determine whether the event joining math and physics are independent. So see, we have a conditional probability and we also are testing for dependent or independent. Makes sense. A complete question in itself, examination style, which you normally see in IB test papers. Okay. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. We provide you with the right questions that can help answer any tough test paper, and that too in the best possible way. I hope it makes sense. Now, let's look into this particular solution. So, we are given that there are 120 total students. For the student chosen at random from these 120, the probability that he has math is one third. So, probability for math is equal to one third. So, out of 120, how many should be there for math? So, the number of students who will take math will be how much? One third of 120, correct? That means total 40 students should take math. Now we have, and the probability that the student has both math and physics is one fourth. So we are also given that probability that, let me change the ink here, probability that both math and physics means intersection, right, is one fourth. So the number of students who have taken both math and physics will be how much? One fourth of 120, correct? Which means 30. Is that clear to you? Right. Now it says there are 20 students that did not take math or physics. How will you write this? This is also interesting to understand. 20 students did not take either. That means number of students who did not take means math union physics complement. Do you understand? Is 20. There is also a very good way of writing which is not asked for in the question, however, important to understand since that may be required in your test. Perfect. Now, based on this, very easy to make a Venn diagram. So, let's make a Venn diagram now. So, we'll have a circle for math, a circle for physics, and of course, they are overlapping. So, we'll write math and we'll write physics. There are, we should begin from inside. And also, whenever you make a Venn diagram, do not forget to make a box. That means the whole population we are looking into. 120 students, right? So normally we write S or U on the top. Right? Let me write S here. Make sense? Follow correct procedures so that you get marks for communication also. Now, 20 students did not do anything. Let's put them outside. 20 are outside. Correct. Now start from inside out. Math intersection P is one fourth. So one fourth will be 30, right? So this 30 comes here. So what we have done here, we have done the number of students who took both math and physics in. Now we can go either side. Total number for math is 40. So 30 are already there. how many left? 10 left, right? So 10 plus 30 is 40. Now we also know that total is 120. So how many will be those which took only physics, right? Only physics, right? So what we should do? We should take away from 120 all the numbers which we have, which is 20 plus 10 plus 30 or 40, I could say, right? And that gives you the number which is only physics, right? So which is 120 minus 60, and that gives you 60. That's right. So we have 60. If you add and check, right? 60 plus 30 is 90, plus 10 is 100, and 20 is 120. It makes sense. So all 120 students have been accounted for. Perfect. Now we've done the first part, which is the Venn diagram. Let's look into part B. One of the students who joined the physics class is chosen at random. Find the probability that the student also taken maths. So, if we say one of the students who joined the physics class, so we are choosing from the category this, correct? From this category. One of the students who joined the physics class, out of 90, we have to find the probability that the student had also taken maths, right? So basically, we are finding the probability that the student has taken math and we are selecting from physics. Get the idea? This P is for physics. Great. So that should be, as you can see, 30 out of 60, right? Because 30 is common to both physics and maths. And total is 30 plus 60, right? Which is 90. So when you simplify, you get 1 over 3. So 1 over 3 is the probability of selecting a student of math if we take it out from the physics group, right? So at least physics has been taken. So it is one third. So that is how we'll find solution for part B. Is that part clear to you? Right? You could also use the formula, right? Which is probability of P and M intersection divided by the probability of P, right? Okay. We are not using it for now. We are using the Venn diagram to answer this question. I hope it makes sense, right? Some of you can try from the other side also and get the same result. Now, part C is determine whether the event joining math and physics are independent. So, there are a couple of ways to find this answer. So, what is the probability of getting math? Figure this out. If you see from here, probability for math is how much? Probability of math is given to us as one third, right? And we see that the probability of math is also same even if we select it from the students who had taken physics. You understand? So what we notice here is that the probability for math is equal to 1 over 3, which is also equal to the probability of student selected from the physics group. And since the math probability did not change, right? So no change, correct? That means independent. Does it make sense to you? Very clearly, we are showing you that the probability of picking up a student who has taken math does not change. Whether you select it just directly from all or from the group which had taken physics. Perfect. So that is how we show in this particular case very easily without further calculations that the probability is independent. The other way could have been also you could find probability for intersection of math and physics, right? That should be equal to probability of math times probability of physics, correct? And in that case also you'll find probability of math is one third, right? And what is the probability of physics? 90 out of 120, correct? because there are 90 students who are taking physics out of 120, correct? And when you multiply this, you do get the probability of 90 out of 20 is, see, let's cancel this, correct? Dividing by 3 gives us 3 by 4, right? One third times 3 by 4, correct? Which is how much? 3 and 3 cancel, 1/4, correct? You see, this 1/4 is intersection and it is same as given 1/4. So the probability of math times probability of physics is same as the intersection which you have seen. So that becomes the second check. However, the first check which I did that did not change is incredible. You need to understand this concept. That saves you not only time but gives you a clear idea of what you are doing. I hope that makes sense. Here is a brilliant question based on probability which we are going to solve using tree diagram. We have a conditional probability case also in the problem. Mr. Sam either walks or cycles to work. The probability that he walks is 0.25. If he walks to work, the probability that he is late is zero point 0.1. If he cycles to work, the probability that he is late is 0.05. Draw a tree diagram to represent the situation. Find the probability that gives Sam that given Sam was late, that he cycled to work. So this is a very critical statement to understand. We are saying find the probability that given Sam was late, that he cycled to work. Perfect. Okay. So let's first draw the tree diagram. So he can go to work either walking or by cycle. So there are two branches. One walk, other cycle. Probability that he walks is 0.25. Therefore, cycling will be 1 minus 0.25 or 0.75. Correct? If he walks to work, the probability that he is late is 0.01. So if he is late, the probability is 0.1. Not late will be 0.9. If he cycles to work, the probability that he is late is 0.05. If he cycles to work, the probability that he is late is 0.05. So this will be 0.95. Correct? So 1 minus 0.05. So each probability you can multiply the given probabilities in each branch and get the answer. So we have a tree diagram. So that's part A. Now let's focus on part B, which is find the probability that given Sam is late. So it is given that Sam is late. So we are talking about probability. That is cycles to work. So cycles and is given that it is late. You get the whole idea. That is the conditional probability. Okay. So he cycles to work and it is given it's late. But the late could be two different ways, correct? Since cycles to work and late means we have to write probability, that is cycles intersection late. You understand? And here we have a probability of coming late. You get the idea. So we can now calculate this. Intersection means he cycles and is late is 0.75 times 0.05, correct? And the probability is late, there could be two ways, which is 0.25 times 0.1 plus the other one, which is 0.75 times 0.05. So that is what you need to calculate to get the answer. Perfect. So I'd like you to do the calculation, write down the answer, and then I'll write my answer in the comments. So I hope that is going to help you. Correct? So do this calculation. Perfect. So with that, we come to an end of this particular video. Check more videos of the similar kind to master the strategies. Let us now understand how do we solve probability based question from application of tree diagrams. Here is a very interesting question for you. On a work day, the probability that Mr. Peter wakes up early is 4 by 5. If he wakes up early, the probability that he will be on time for work is P. If he wakes up late, the probability that he will be on time for work is 1 over 4. Draw a tree diagram to represent the situation. Find the value of P if the probability that he arrives to work on time is 4 over 5. You can always pause the video, answer the question, and then look into my suggestion. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we have many related questions. They can help you to master the strategies. All those videos are free. However, if you want to learn directly from me, you can send an email on globalmathinstitute@gmail.com. Now, let us draw the tree diagram for the given situation. On a work day, the probability that Mr. Peter wakes up early is 4 over 5. So, first branch will be wakes up early, right? So, wakes early. So, the next option, which is complementary to this, is wakes late, not early. If 4 by 5 is the probability for early, 1 minus 4 by 5, which is 1 over 5, will be the probability of waking up late. If he wakes up early, the probability that he will be on time for work. So that's the next branch. On time and not on time, right? Or late, right? So on time or late. This is for work. Now for work, if he wakes up early, the probability that he will be on time for work is P. And late will be 1 minus P, correct? If he wakes up late, the probability that he will be on time is 1 by 4. So here it is on time or late. That is at work. So on time is 1 over 4. So late will be 4 minus 1, which is 3 by 4. So that is the tree diagram which we have. Draw a tree diagram to represent the situation and then find the value of P if the probability that he arrives to work on time is 4 over 5. So we are given that the probability is on time to work, right? So this was second branch. So on time to work, we are given the probability is 4 out of 5. Now from the tree diagram, you can see that there are two ways to arrive on time. So if you get up early, Peter gets up early, in that case, the probability is P. So one option here is 4 by 5. Now these are independent events. So he gets up early and is on time. So and is on time means you'll multiply them. So 4 by 5 times P plus the other option 1 by 5 gets up late, but the probability of reaching on time is 1 by 4. And this is 4 by 5. You get the whole idea. So that is the equation which will give us the solution for P. So you need to now pause the video, calculate P, and then check my answer, right? Great. Now here's my solution. You see that the lowest common denominator is 20. So I can multiply everything by 20, and so this equation now becomes 16p plus 1 equals 2. If I multiply this by 20, then 4 times 4 will be 16. Correct? So 4 by 5, 1 by 5, all these things are given to us. I'm multiplying everything by 20. So when I do that, then for P, 20 divided by 5 is 4. So 4 times 4 is 16. Here 20 over 20 is 1. And once again, 4 by 5 is 16. So now 16p is equal to 16 minus 1, which is 15. And so the value of p is 15 over 16. You see that. That is how we are going to find the probability, find the value of p from the given probability. I hope that makes sense. Here is another video which is based on conditional probability. It is extremely important topic. You're going to understand few strategies. How do we solve conditional probability questions using concept and using a formula? I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to master strategies, you can always send an email on globalmathinstitute@gmail.com. Our students are right there on the top. You can also watch the playlist for many related examples. Here is a very beautiful question based on conditional probability. A person is known to speak truth 3 out of 4 times. He throws a dice and reports that it is a 6. Find the probability that it is actually a 6. Great. So, in such questions, you can define the events. So, first event which I'll define is speaking truth, right? So probability of speaking truth. So, T for truth is given to us as 3 out of 4. Now, when you write probability of speaking truth, probability of not speaking truth, that means T bar or T prime will be 1 minus 3 by 4 or equals to 1 by 4. It's important to understand the information given to us. The other thing we are talking about is the event of getting a 6 in a fair die. So probability to get the number 6, right? Now, since this is 1 over 6, we can also write the probability of not getting a 6, right? So again, I'm using this notation, not 6, okay? So that should be 1 minus 1 over 6, and which is 5 over 6. So we have defined the two events. Now we're saying find the probability that it is actually a 6. Means he is speaking a truth. You get the idea, right? It is a 6 and he is speaking a truth. Now let's try to understand this scenario. There could be two conditions, right? One, that it is a 6, and the other one, it is not a 6, right? So that means it is a 6 or it is not a 6, correct? Now, he can say that it is 6 by telling truth here and not truth here. Do you see? There are two different ways that you get a 6. And that should help you to answer the question. Perfect. So when we talk about conditional probability, we know that First condition is that we have a 6. So, what is the probability of getting 6 that comes in the denominator? So, we can write probability that it is truth, right? And actually, it is a 6, right? So that is what we are looking for. Probability that it is truth and it is a 6. Now, since we are talking about probability, it is truth and 6, then their probability should be probability of truth times probability of getting 6, correct? And total number of ways in which you can get a 6 is if it was really a 6 and he is speaking truth, that is the same thing, that is probability that is truth and it is a 6. But there is another way of getting it, and that is it is not a 6 and he is telling a lie. So, not a 6 means 5 by 6, right? So, it is, and he is telling a lie means not truth, right? So, we can write probability for not truth and probability for not 6. You get the idea. So, that calculation should give you the right answer. Perfect. So, here is your solution. I like you to sub in the values and figure it out. Correct? Let's take it on a new page and show you the calculations, right? So, we are saying that probability that he is speaking truth and it is 6 is basically equal to probability that it is truth and it is 6, correct? Plus different ways of getting 6 is definitely is speaking truth when we get 6, correct? Or he's telling a lie, right? So or means add, he's telling a lie where it is not a 6, right? So when it is not a 6, correct? So let's plug in the values. Speaking truth is 3 out of 4, right? So we'll write 3 out of 4 is speaking truth, and probability that is 6 is 1 out of 6, correct? And you have to divide by 3 out of 4 times 1 out of 6 plus not truth will be 1 out of 4 and not 6 will be 5 out of 6, right? Okay, we need to now simplify this. So you see 4 times 6, 4 times 6, 4 times 6 is a common denominator, and therefore we can write this as 3 over 3 plus 5. Is that clear, right? So that gives you 3 out of 8 is the probability that he's speaking truth when he says that it is a 6. You get the whole idea, right? So that is how we are going to answer this particular question. I hope the concept is absolutely clear. Here is extremely difficult test question which most students could not answer correctly. It is based on Venn diagram. A, B, and C are three events with probability of A 0.25, probability of B 0.4, probability of C 0.45. Probability of A intersection B intersection C is zero point 0.1 and probability of A intersection not B intersection C is 5. Given A and B are independent, B and C are independent events. So A and B and B and C both are independent events. Part A is to find the probability of A intersection B and probability of B intersection C. Part B is state with reason whether event A and C are independent or not. And C, of course, is to draw the Venn diagram to illustrate the probabilities. I am Anil Kumar. Welcome to our series on probabilities. In this playlist, you'll see many other videos related to this, and I hope they will give you good practice to answer such questions. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Let's begin with answering part A, which is find probability of A intersection B and probability of B intersection C. So let's label these events as A, B, and C. So we have A, B is the green one, and C, the blue one for us. And that is the universal set. We are given that the probability of A intersection B intersection C is zero point 0.1. So let's begin from inside out. Let's write down zero point 0.1 as the intersection of all the three. So that is this, correct? Now the second condition given to us is probability of A not B intersection and intersection of C is null set. Now which is this area? Now this part is very critical to figure out. So let's now work on this part, which is probability of A intersection not B intersection C. Phi means null set, right? Perfect. So let's first find what is probability of, let's rearrange it, right? So it is intersection of A, C, and then we'll do intersection of not B. Is that clear to you? That is given to us as phi. Now when we talk about intersection of A and C, means we are talking about all this, correct? So that becomes intersection of AC. Is that clear to you? And when you do intersection of not B, in that case, the region which comes up is this. You get the idea. So probability of this region is phi means 0. You get the whole idea. So that is what it is. So we have shaded this and that probability is 0 as you've seen here. Now that should help us to answer the question easily. So at this stage, I'll request you to pause the video and answer. Now let's find probability of A intersection B. So what is the probability of A intersection B? Probability of A intersection B. We are given that they are independent events, means it is product of their probabilities, right? So product of A is 0.25, which is quarter, multiplied by 0.4. So quarter of this will be 0.1, correct? So probability of A intersection B, A intersection B is the region, and since we have 0.1 already, so that means this probability is also 0, right? Correct? So you see how that really helps us to find the probability in the Venn diagram also, right? Now let's move on and find probability of B intersection C using the same concept, right? So probability of B intersection C, since they are independent events, right, is probability of B times probability of C, which is probability of B is 0.4 and that of C is 0.45. So let's multiply zero point 0.4 with 0.45 and we get this as 0.18. So we're talking about A, B, and C, and the intersection. So let me fill this up. This point is given to us as 0.1. Now, here there's nothing we know, and here also there's nothing. Now, probability of B and C intersection is 0.18. So, this portion will be how much? Since we already know that A, B, and C intersection is zero point 0.1, this should be 0.08. Makes sense, correct? So, from this probability, we can also, as we move along, fill in the Venn diagrams, right? So I hope that part is clear. So let's move on and further do our calculations. We just calculated A, B, and C. This was 0.08, right? State with reason whether events A and C are independent or not. So probability of A and C. Let's figure this out. So let's find probability of A intersection C. So probability of A intersection C is given to us as 0.18, right? Probability of A intersect, no, sorry, zero point 0.1. Probability, now let's answer part B, which is state with reason whether event E and C are independent or not. So from the diagram, we can see what is the probability of A and C, right? Probability of A and C is this region, which in this case is zero point 0.1. Now we need to check whether it is equal to probability of A times probability of C or not, right? So if you multiply A and C, I get 0.25 times C probability 0.45, correct? Which is equal to 0.25 times 0.45 is equal to 0.1125. And since this is not equal to zero point 0.1, I mean it is not equal to probability of A intersection C, we say they are not independent events. Is that part clear to you? Perfect. See, that is how we are going to answer these questions. And now let's move further and complete the Venn diagram. So we know these three events A, B, and C, intersection of each is zero point 0.1 and that of this is 0.08. Let's fill up the other things. We know that the probability of A is 0.25, right? So in A, we already have zero point 0.1, so what remains is 0.15. Correct. We also know probability of B is 0.4 from the diagram. To get this region here, it will be how much? It is going to be, we can calculate 0.4 minus 0.1 minus 0.8, right? So zero point 0.4 minus 0.18. So that gives us 0.22. Probability of C is given to us as equal to 0.45. So what will come here? It will be 0.45 take away 0.1 and take away 0.08, right? So that will be 0.45 minus 0.18 which is 0.27. Now we can add all these terms and see what should be outside, right? So, so not ABC is how much? 1 minus, let's add them all, right? So it is 0.15 plus 0.22 plus 0.18 plus 0.27. So it should be equal to 1 minus 0.15 minus 0.22 minus 0.18 minus 0.27, and that gives you 0.18. So 0.18 is probability of not A, B, or C, correct? So that is how we can complete this particular solution. I hope the steps are absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.